is much bigger than your screen now. Okay. But I want to just bring about two examples that we talked about it today. One more example, and with another fraction. Again, before we go into our expert workbook. So yesterday, the first question, the first story was Amara having half of it. Right? I said the whole here is for reference. Then I said Amira has half the cake. Then I said Angel came by and asked, hey, Angel says, I want half of whatever you have. Okay? And yesterday we figured out that most of us figure out that it's this size. This one. Correct? So we said, Angel said, I want half of whatever you have. That is actually half of half. So it means in calculation, half over half, which actually gives us a quarter. But then again, before this, we get a quarter that shows here. Angel says, I want half. Half of whatever you have. How come you are not picking out this price? You say half, right? Angel says, I want half. Derek? That is just. Thank you. Okay, this is what Derek says. Angel says, I want half. But this half is not half of what Amara has. This half is the half of the cake. Alright? So actually, it means this way. I mean, I'm chopping Amara's half into 2 pieces, and then I get like this. This is half, right? This is Amara's cake in quarters, and then this is half of the half, and that's the fraction we are looking at. And then yesterday we say the working is I can do as numerator times numerator, and then denominator times denominator equals. Okay, then we move on to the next example, which was for the declare having half the thing as well. Okay. So Pranavika has also half a cake, but Ryan came by and says that I want 2/3 of whatever you have. And then in yesterday's video that I recorded, we go back and take a watch it already. You notice I ditched him this. And I said, Ryan, 2/3, right? Like that. Then he happily take this. Yeah, 2/3. I asked him, is this 2/3? He said, yeah, this is 2/3. And I said, okay, like that. Okay, look at here. Finish. And some of us said, oh, this is correct. It's Pranavika only have like this. How come Ryan go ahead and come up with like that? Because bigger than what Pranavika has. Right? Then after that, Stella came over and then he said, no, that's not how it goes. 2/3 of half. He said, well, it's this piece. Okay? He put it like that. Okay, then he say, oh, this is correct. Then I look at it, it looks like it's correct. Then he wrote. So you see, like this, right? Equivalent fraction. So I times 2 times 2. The equivalent fraction is like that. Then what is the mistake I said in me? Yeah, wait a minute, Skylar. Remember, Ryan wanted 2/3. It's not exactly 1/3. But how come this gives the correct answer 2? Yes. Yeah. So we agree. Now look, when Ryan says I want 2/3 of whatever you have, this is not the 2/3 we are looking at. This 2/3 is the 2/3 of the whole thing. Okay? It's not the 2/3 of what Ryan. So to make this become thirds, I need to chop it into three slices. And I get 2 out of 3 slices. Then you can get what I'm saying. So this working actually is you get 2/3 of the halves that Ryan that Pranavika has. I can actually do simplification, or I can just numerator times numerator, denominator times denominator. That gives me 6. And I can simplify to 1/3. Which eventually you realize that, hey, this is what Ryan is getting. But what is 1/3 is what now? Is it 1/3 of Pranavika's state? Thank you, Sasha. This is 1/3 of the movie. So the answer at the end is actually talking about Ryan having how much of the whole cake eventually. Do you understand? Now, the thing is this. In case of when we learned non-racial fractions previously, we also mentioned before. If possible, I try to simplify. So I can simplify as easier. And I will actually also get 1/3 very quickly. So this simplifying works is because you already know that 2 of these you make 1 of these. So that's how the simplifying works. You understand? Okay, now let's change a different story. No more halves, let's go with 1/3. So we change this story out a bit. The next example. Okay. Okay, so the next example comes. Let's say Daniel is very kind, so he has 1/3 of the cake. He probably gave the other pieces away, to other people to eat up. So he only has 1/3 of cake left. Right? And then Adrian comes by. Adrian comes by. Hey! Okay. I want 2. Okay. So Adrian comes by and says, hey, Daniel, I want 2/3 of whatever you have. Okay? So I can say 2/3 of 1/3. What will be the answer? Again, pick a fraction. So Daniel, it's Daniel now. Daniel is 1/3 of a cake. Come, Adrian, pick a fraction. All right. Is there something you are thinking about? It's going to my recording. as well. So Daniel has 1/3 of the cake. Again, he doesn't have the whole cake. He only have 1/3 of the whole cake. Okay, and then let's see. He has this 1/3. Adrian says, I want 2/3 of whatever you have. Okay, just now we saw that the first example started with half, right? Now then, Ryan was 2/3 of this half, right? So what we did was to cut this half into 3 parts, and then take 2 out of 3. That's how the 2/3 became. So now it's still 2/3. Okay. Again, is it the same? These 2/3? No, it's not. Because this 2/3 is the whole thing, not this. Then what is it? Well, it's 1/3. Using this same idea, what did I do to Daniel's cake? Yes. What will I do to his cake? Follow this idea. Okay. How do you learn this? Okay, try to draw as simple as possible. Okay, now try to see which 3 pieces fit there. Any suggestion? Some of our friends say try the 9. Denominator 9. How come you're so fast again? So you put us yeah, you did. So Adrian, exactly how much of the did you get? Yes. Nice. Very good. Okay, thank you. Let's give your back to Adrian. Yeah. Very good. Let's get the honestly during the test and exam time, we will say that I try drawing, okay, to help me if I cannot answer. That is a possible idea. But the truth is also it's going to be quite challenging for certain fractions. And if the fractions go, the denominator goes up higher, it's even harder. Okay, so what happens is now I have 2/3 times 1/3. Then I ask myself the same question. Can I see? No, not really. I can use the same formula, the numerator times numerator, denominator times denominator. I get answer. Now, how did this actually make sense? It's actually, yeah, how you explained it just now. I'm cutting this 1/3 into 3 parts. Okay, and for the 2/3 to happen, I'm taking 2 pieces. But you realize that the denominator has changed to 9. So this denominator 9, what is it based on? Thank you. Who said that? Okay, very good. This 9 is based on the whole thing. It's not based on Daniel's cake anymore. Is that okay? Okay, good. Now we take up our textbook. Okay, I'll show you the textbook. Okay, so now you take out your textbook, you should be able to see the examples that I stated. Now, the difference that is given here is you can see how bar models can be used instead of pizzas and fraction Ds. Okay, like this one here, 2/3 of 1/3. This is the example that I gave you just a moment ago. So this 1/3 is the part that is given, and then you cut it into another 3 parts to get your 9s. So the example is here. You can see other examples here, the following page as well. Now, I'm going to skip on to this question here. In a work problem. This is the bar model. Okay. It shows you Mrs. Tan has 3/4 kilogram of flour. And you see, you realize that this is drawing 3 units of the whole kilogram. So maybe there's just 1 whole kilogram. See this one? There's this 1/4 that's missing from it to make the whole kilogram. Then she used 1/3 of this amount that she had to bake a cake. So from this 3/4 is taking 1/3 of it, which actually out of the whole cake is 1/4. So that's how the model looks like and how the steps to it and simplifying works. Okay? Okay? Okay, if you are ready, I'll give you the worksheet. We are going to try it out. Okay, so we are at the topic of okay, we're at the topic of multiplying 2 proper fractions. The first 2 stages deals with the working steps. Then we move on to some word problems at the back. Okay, now we are going to go to question 80 first here. Question 6 of page 80, sorry. Question 6 of page 80. Okay, these numbers looks a bit challenging. Let's go with page 80. Page 80, I'm on page 80. Yeah? Question 5 instead. Question 5 is slightly less. Difficult because of the numbers. Okay, quarters and half are still easier to see. Now, if I look at this example, this question 5 of page 80, I'm going to share screen now. This is the one. Okay, if I use this fraction, this to explain question 5. Sally has a box of buttons. This is the entire box. And then 3/4, let me put this box as a gray box. It's a gray box. In this box, 3/4 of the buttons are red. 1, 2, and 3. You can see? Now, so 3/4 of these buttons are red. Half the buttons, the red buttons, that means I have 3/4 here, I'm going to shift them out. These are all the red buttons. Half of them are round. Is this the one I'm talking about? No, again, it's not. This half is, yeah, yes, half of the whole box. So this is not the one. So what would it be? If I want to draw, if I want to say it's a half, right? That means I'm like cutting, remember? This whole thing I cut, I slit off like this. Right? What fraction do you suggest I use? Let's talk about the denominator first. What denominator do you suggest I use? Can you see this line, this blue line that I'm drawing? Okay. I draw this line here to like cut this quarter up. What do you suggest to say like maybe this will give me half? What do you suggest the denominator? Yes. 8. Okay, I'm going to try 8. Does it look like it will work? Yeah? Yes, not bad, right? Okay, so if I were to use bars instead, okay, let me use bars instead. Okay, so same thing, I have this one hole. Okay, then I have 3/4 that's red. Okay, so if you want to say, I want to draw a model to help me to answer the question, this is how you will draw. I will take this one hole and I will cut it into quarters. And then it's 3/4 like this. Then out of this, I need to cut here. Half, which for round buttons, like this, 8. So 8 is a good idea. Oops. Okay, let me try to draw it so that you can also draw it. Okay, so let's say if I were to do drawings in pencil. I have a box of buttons. It is one whole box. Out of this whole box of buttons, I cut it into quarters. I cut it first by half and then into quarters. Now I'm talking about these parts here. This 3/4 of all buttons are red. So half of the red button is, this is 3/4 of all the buttons. So I'm actually going to take 3/4 is this whole piece. This is 3/4 that's all red. Then for the round button, I'm cutting half here. Which if I cut half for this piece, I'm also going to cut half for everything. So half of the red buttons will actually be this. This is how to draw a model, a bar model for it. Then how to solve? So I have half of the red buttons are round. So that is half times 3/4. Numerator times numerator, denominator times denominator. That's how the steps are. And I get 3/8. Now, I do not have to draw every model if I'm already able to understand and solve by the working steps. So the next question here. 4/5 of all the pupils are swimmers. So 5A class, all students or all pupils, that's one whole. All of this one whole, 4/5 are swimmers. 2/3 of the swimmers are boys. Of the swimmers, the swimmers is 4/5 of all the pupils. So you want to find out the boys who are swimmers. That's 2/3 of the swimmers, not all the pupils. There will be 2/3 times 4/5. I can do numerator times numerator, denominator times denominator. The answer will be 8 out of 15. And by this denominator of 15, we understand this is of all pupils. So this is the part of all pupils. So from 2/3, we change it to 8/15 of all pupils. The 2/3 of the swimmers are actually 8/15 of all pupils. The same as for this one. Question 5. 3/4 of the buttons are red. Half of the red buttons. In the end of the day, the question is asking for the fraction of the buttons that are red and brown. So this answer here, 3/8, by the denominator of 8, we are also able to explain that it's 3/8 of all the buttons. It's not 3/8 of red, it's not 3/8 of the red buttons, but it's 3/8 of all the buttons. That makes up the red and the round. Is that okay? Okay? Okay, so question 3 and 4 DIY. Can? Do you feel like you can do it or you need some explanation still? Okay. So here at Aisha, we do a bit of it. Okay, then you try to solve your own. Aisha has this amount of onions. Not the whole kilogram, but 5/8 only. She used 1/5 of each. Each is the sliced onion. Again, if you feel like when you see the fraction, you already feel scared already. Then you read the problem without the fraction. So I can say Aisha had some onions. She used part of it to cook curry. What is the mass of the onions used? So I have used to cook curry is 1/5 of the onions.
So 1/5 of the onion is 1/5 times 5/8. In this case, I can simplify. And I get 1/8 kilogram. Now, how does this make sense? I can draw the model again. If I have a 1 whole kilogram, 1 whole kilogram of onions, I only have 5/8. That is sliced onions. So I draw 8, cut into quarters, then into 8s. So actually, I only have 5/8 onions. 1, 2, 3, 4, 5. Now, if I look at this, is 5/8. These are onions. 5/8 of the whole lot of kilogram is onions. Then it says 1/5 of this onion. If that means this one, I don't need to care. This 3/8 is not important. I look at only these 5 units. Then it says 1/5. Hey, just nice. Actually, 1/5 is here. 1, 2, 3, 4, 5. Already have 5 units. So 1/5 of it is 1/8 lor. Out of the whole kilogram, this 1 unit was the 1 unit out of the whole. Is it okay? Can? Okay. Then the last one here. He has some pocket money, but he didn't spend all the pocket money. He only spent part of the money. Okay, so I can, if I were to draw a bar model, this is his whole pocket money. But he didn't use all the pocket money. He only used 9 out of 10. So I draw 10 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 10 units. One piece is safe. Spent this 9 pence. That's the whole. This is the whole pocket money. This part here is safe, so no need to care. Safe. Okay, don't need to care. 9/10 is spent. All of these 9/10s, out of this amount means 9/10. Out of these 9 units, 1/3 spent on food. How to get 1/3 from this? Yes, Darren. Yes, it's 1/3 of the 9/10. So if I say on food, right, is 1/3 of the money spent. Is yes 1/3 times 9/10. 1/3 of the 9/10. Which is I can simplify this, and that gives me 3/10 of all the money on food. But how come it's 3? So it's like this. The answer that is here, 3/10 on pocket money, is this one here. This one is food. That's why I say 3/10 is on food. But how do you get to this? How is this 1/3? Can you see that if I group this is 1/3. This is 1/3. And this is also 1/3. Can you see? Okay, can you understand? So this is where how it makes sense. I regroup it. Earlier on, I'm cutting things up into smaller parts, even smaller parts. Now I'm actually grouping them to make thirds. Is this okay? Can you understand or not? So I'm actually, there are 9 units. Out of these 9 units, okay, 3 units, 3 nines. It's also 1/3, 3 nines. That's 1/3. So three units is food. Now, how is it 10? It's because the whole pocket money is actually 10. Can you understand? Okay, so this one I help you already, no more DIY. Now, if you didn't manage to catch it on time, this is recorded, so you can go home and look at the model drawing again and try to draw. Sometimes the drawing can be very challenging. Okay? But with some practice, you'll be better at it. Okay, now. Huh? Question 6. Question 6, you go back and watch the video. I want to talk about your homework. Your homework is on page 79. Okay? Homework is page 79. I will go through this question here, straight to show the answer. So half of this 1/4 actually means I'm cutting this part here into 2 further parts. Half of the quarter. That makes it 1/8 of the whole rectangle. And then this one, 2/3 of the half. This is the one that we have been looking at as an example quite a bit already. So I'm cutting this half into 3 parts, which is like if I were to cut everything into, then you realize that okay, 2/3 is this one and this one, which I can simplify this into one third. This piece is a 6. Okay? Okay, so the rest of the questions for you to do. All right? Okay, quickly is